In this video, we are going to graph a couple of absolute value equations. Now, absolute value equations always form some sort of a V. So just keep that in your mind. Sometimes it could be a right side up V or an upside down V. But it's always a V, and the extreme point at the bottom or the top is called the vertex. Now, the first thing to know is how to find the vertex. The vertex is always going to be the opposite of the inside number, comma, the outside number stays the same. So the vertex is going to be 3, comma, negative 4. The opposite of this one, and then this one stays the same. So let's go ahead and plot that. So 3, comma, negative 4 is going to be right here. That's the vertex. Now notice how this is positive. That means it's going to be an upward facing V like this. Now the next thing to think about is the slope. Maybe I'll stick with this. Because the slope is 2, that's like 2 over 1. So from the vertex, I will go up 2 over 1, like this. Up 2 over 1 repeatedly. That gives me the right-hand side of this V. Now for the left-hand side, I'm just going to do the mirror image. So instead of going up to right 1, I'll just go up to left 1 like this. All right, so we've done it. All we need to do is connect these with a segment, or technically we should do a ray, so why not go ahead and actually do a ray. And that's how you graph an absolute value function. Let's talk about the axis of symmetry, the domain, and the range. The axis of symmetry is the vertical line that splits this right down the middle. All right, it's the reflection line between the left side and the right side. So you can see that the axis of symmetry, if we were to draw it, it would be right here. Okay, this is the axis of symmetry. So that's going to be the line x equals 3, because it's a vertical line at 3. Now the domain, as always, is how far it goes to the left and to the right. This graph goes to the left forever and to the right forever without any breaks. So that's going to be negative infinity to positive infinity. Now the range is not so extreme. The range goes from bottom to top in that order. The order matters. The bottom of the graph is here, so we're going to begin at negative 4. All right, and I'll use a bracket because it touches negative 4. It needs to be included. So this is the bottom of the graph, but there is no top. It goes up forever. So negative 4 to positive infinity. And that's going to be the range. And that is all we needed for problem number 1. Okay, let's take a look at problem number 2. Again, the first thing to do is determine the vertex. It's going to be the opposite of this, comma, this stays the same. So the vertex will be negative 4, comma, 3. We should go ahead and plot that. Negative 4, comma, 3 would be right there. There's our vertex. Next, look at the slope. This is negative 1 over 2. All right, if it were a positive 1 over 2, that would mean up 1, right 2. Because it's negative, it means down 1, right 2. Notice that we always go to the right. If it's positive, we go up and to the right. If it's negative, we go down and to the right. But we always go to the right. So I'm going to go down 1, right 2, again and again. That gives us the right-hand side of our V. Again, absolute value functions always make some kind of a V. If it's negative, it'll be an upside down V, like this. If it's positive, it's a right side up V. So we're looking for an upside down V. This is the right hand side. The left hand side, I will just do the mirror image like this. Okay, so we've basically graphed it. I'll just go ahead and draw some rays. Okay, so now we've really graphed it. Anyway, so that's that. Of course, the axis of symmetry is the vertical line right down the middle. Okay, so this is the axis of symmetry right here. So that's a vertical line at -4, so x equals -4. Don't just put -4, put x equals -4. The domain, well, the graph goes left forever and right forever, so that is -infinity to +infinity. Now the range is always read from bottom to top. At the bottom, this graph goes down forever, so that's going to be -infinity. But it doesn't go up forever. This graph stops here at 3. So -infinity to 3. And we'll put a bracket because it touches 3. It's included. So that's it for problem number 2. And that is how you graph an absolute value function. It's pretty simple.